Everything you see, the sun, the stars, your own heartbeat, is part of a slow-motion car crash that began 13.8 billion years ago. We are taught that the universe is building toward something, but the cold hard truth of physics is that the universe is actually unraveling. We call this process entropy. It's being called time's arrow, the tax of universe, and the death of energy. But most people get it completely wrong. Today we are going to climb 10 levels of understanding to see why entropy is not just about a messy room. It is the reason you exist, the reason time moves forward, and the reason everything must eventually end. Let's start at the bottom. Level 1. The illusion of disorder. Entropy is not messiness. Level 1 is where we kill the biggest myth in science, the idea that entropy is messiness. We've all heard it, my room is high entropy because it's a mess. But to the universe, messy is just a human opinion. Imagine two rooms. Room A is a minimalist masterpiece, everything in its place. Room B looks like a tornado hit it. If you were an atom in those rooms, you would not see order or chaos. You would just see positions. Total energy and matter are identical. The universe doesn't have a cleaning lady who cares about where your socks is. Physics cannot distinguish between these states based on neatness. The reality is, messiness is a subjective human judgment. To the universe, a perfectly ordered room and a totally trashed room contain the exact same amount of matter and energy. If entropy is not just about a messy room, what is it actually measuring? If the universe doesn't care about our visual clutter, what does it care about? It cares about how energy is distributed, and that leads us to the waterfall of physics. Level 2. Diffusion and degradation. Level 2 is the degradation engine. Imagine a waterfall. Water at the top has potential. It can turn a wheel as it falls. But once it's in the pool at the bottom, the water is still there, but its power is gone. In 1824, Saudi Carnot realized energy works the same way. He discovered that energy only does work when there is a difference in temperature. Energy only flows and does work when there is a gradient, a difference between hot and cold. In 1865, Rudolf Clausius coined entropy to measure this spread. Energy never vanishes. It simply degrades from a highly structured, useful state into useless ambient background heat. Energy is like money in a bank. Concentrated energy, for example, a hot battery or a hot cup of coffee, is like a $100 bill. It's useful, but as that heat spreads out into the room, a process called diffusion, the money is not gone. It's just been turned into a billion pennies scattered across the floor. You still have $100, but you cannot buy anything with it. That scattering is the beginning of entropy. Level 3. The death of useful energy. Building on that, level 3 is the entropy tax. Rudolf Clausius realized that every time energy moves, a little bit of it escapes into the background. Think of it like a delivery truck. The truck carries fuels or energy to a destination to do work, but the truck has to burn some of its own fuel just to make the trip. That lost fuel becomes exhaust useless heat. This is the second law of thermodynamics. The total amount of energy stays the same, but the quality of that energy, its usefulness, always goes down. Entropy is the measurement of that uselessness. So energy is spreading out and becoming useless. But why does this only happen in one direction? Why don't the pennies on the floor spontaneously jump back into a $100 bill? Level 4. The arrow of time, the only law that cares about the past. Level 4 is the reason you can't unscramble an egg, and is where we meet the director of the cosmic movie. You see, almost every fundamental law of physics, from Newton's gravity to Maxwell's equations and even Schrödinger's quantum world, is time-symmetric. This means the math works exactly the same way forward as it does backward. If you saw a high-definition video of two atoms colliding, you wouldn't be able to tell if the film was playing in reverse. In the micro world, everything is reversible. But the moment we zoom out to the macro world, our world, that symmetry shattered. A video of a broken egg spontaneously reassembling itself feels instantly absurd. Why? Because entropy is the only law of physics that demands a specific direction. This is the arrow of time. Imagine a deck of cards perfectly sorted by suit and number. That's a low entropy state. You start shuffling. The deck becomes random. No matter how many billions of times you shuffle, those cards will almost never return to that perfect sorted order. This cosmic shuffling is what we experience as the flow of time. Yesterday was a slightly more sorted deck. Tomorrow will be more shuffled. Time itself doesn't push the egg to break. The breaking of the egg, the inevitable increase of entropy, is that creates our perception of time moving forward. Level 5. The probability grid. Entropy is just a statistical inevitability. Now we have to ask, why is the arrow of time so stubborn? Why does the universe seem so obsessed with breaking things? In level 5, we look at the probability grid. As the physicist Jeff Phillips explains, there is not actually a mysterious force or a cosmic bully pushing things toward chaos. It's actually just a game of pure cold numbers. Imagine a grid of 100 empty boxes. If you take 10 balls representing units of energy, and you put them all into just one box, that's a low entropy state. There is only one possible way to do that. But if you let those balls bounce around randomly, there are trillions of ways for them to be spread out across the grid. Nature doesn't prefer the spread out state because it's better or fairer. It's just that there are so many more ways to be messy than there are to be perfect. High entropy isn't a choice, it's a statistical certainty. This brings us to the tragic genius of Ludwig Boltzmann. He looked at things like heat flowing through a metal rod or dye spreading through water and asked, is there a physical push happening here? The answer is no. It's just the casino of the universe. Imagine two solids, A and B, joined together. Solid A is hot, packed with quanta of energy, while solid B is cold. As the atoms vibrate and bump into each other, they trade that energy back and forth like players swapping cards in a giant internal casino. Statistically, there are only a handful of ways for all that energy to stay handled in solid A, but there are trillions upon trillions of ways for that energy to be split between A and B. Entropy is simply the measurement of these possibilities, which we call microstates. It's the count of how many hidden microscopic ways a system can be rearranged while still looking exactly the same to us on the outside. In 1877, Boltzmann provided the current definition of entropy. Boltzmann was so proud of this discovery that he had the formula carved onto his tombstone. It says that entropy S is simply the logarithm of the number of possible microscopic arrangement, W. Level 6. Information is physical, the physical weight of a memory. Now we get into the truly mind-bending stuff. Level 6 suggests that entropy is not just about heat or steam engines. It is about information. It turns out that a thought or memory has a physical price tag in the universe. In 1867, James Clerk Maxwell imagined a cheat to the second law. He pictured the tiny, intelligent creature, Maxwell's demon, standing at the door between two chambers of gas. The cheat is like that. The demon watches the molecules. When a fast, hot molecule approaches from the right, he opens the door to let it into the left side. When a slow, cold molecule approaches from the left, he lets it into the right. Without doing any work in the traditional sense, he sorts the gas, creating a temperature gradient out of thin air. He has efficiently reversed entropy. How does the universe prevent this cheat? For a century, physicists were stumped. The answer finally came from the world of computing and a concept called Landauer's principle. To sort the molecules, the demon must first observe them. Then he has to record their speeds in his memory. Eventually, the demon's memory fills up. To keep sorting, he has to erase old data to make room for new observations. Here is the kicker. Erasing information is a physical act. Rolf Landau proved that erasing just one bit of information, flipping a 1 to a 0, generates a tiny, unavoidable amount of heat. This heat released into the environment perfectly offsets the entropy the demon removed by sorting the gas. Information is not a ghost, it is a physical entity. You cannot organize the world without paying for it with information, and you cannot clear your mind without heating up the room. In the 1940s, Claude Shannon, the father of digital age, realized that Boltzmann's math for atoms was identical to the math for communication. He defined entropy as a measurement of surprise. Imagine a book where every single page just says the word "the." That is the low entropy state. It's highly ordered and incredibly predictable. You have zero surprise. But a book where every letter is chosen at random as high entropy is full of information because every single character is a surprise. In physics, entropy is just a measurement of the hidden info of atoms, the trillions of tiny surprising details about where every particle is and how fast it's moving that we simply cannot see from the macro scale. But here is the big question. If the universe is a giant book that is slowly being filled with random, high-entropy gibberish, why do we see stars, galaxies, and people? Why does anything clump together at all? For that, we have to look at the one force that seems to love clumping more than everything else. Level 7. The gravity paradox. In the cosmos, clumping is chaos. Level 7 is the gravity paradox. Gravity seems to fight entropy. It takes clouds of gas and pulls them into beautiful, ordered spheres called stars. Does gravity break the second law? The reality is no. Gravity is actually the ultimate entropy doubler. When gravity pulls gas together, the gas particles crash into each other and get incredibly hot. They radiate a massive amount of waste heat out into the dark universe. Gravity is like a high-speed construction crew. They build a beautiful skyscraper, the stars, but they produce so much trash, noise, and heat in the process that the total mass in the city actually increases. Gravity creates local order at the cost of massive global chaos. Level 8. The biology of consciousness. Life is the entropy engine. If stars are the universe's giant entropy generating furnaces, where does that leave us? Are we some kind of rebelling against the second law? Level 8 reveals a startling truth. Life is not a violation of entropy. Life is the entropy engine. We often ask, what do we get from the sun? Most people answer, energy. But if you look at the cosmic ledger, that is not quite right. Earth is in a state of thermal balance. Our planet radiates almost exactly as much energy back into space as it receives. If we just kept the energy, Earth would simply melt. So what we actually harvest from the sun is low entropy. Think of the sun's incoming light as a neatly folded shirt, highly organized and ready to be used. We take that order, use it to drive our metabolisms, build our bodies, and power our cities, and then we vomit out that energy as wrinkled, dirty laundry, useless, disorganized waste heat. As the legendary physicist Edwin Schrödinger famously put it, life feeds on negative entropy. The universe's default setting is decay, and life only survives by acting as a funnel. We maintain our internal sharp geometric order, our DNA, our neurons, our very consciousness, by destroying the concentrated order of our environment at an even faster rate. So what is in the cosmic ledger? Let's look at the energy balance sheet. For example, if Earth receives one high energy photon, low entropy from the sun, in the process, we use that concentrated packet of order to maintain our complex structures. The output is that we exhaust roughly 20 low energy photons, which is high entropy, back into the dark void. We are not just living in the universe, we are surviving on the gradient between the sun's intense order and the freezing chaos of deep space. We are the brief, complex patterns that emerge while energy is on its way to becoming useless. But what happens when the sun eventually burns out? What happens when every folded shirt in the cosmos has been unfolded, and every gradient in the universe finally disappears? To see the end of the story, we must look into the far, far future. Level 9. The deep freeze. The heat death of the universe. We've reached the endgame. Level 9 is the heat death. the final destination of the second law of thermodynamics. If entropy is a measurement of energy spreading out, then the heat death is the moment that energy has nowhere left to go. Every cosmic waterfall will have finished its fall. Every star will have caught up its last bit of light. Even black holes, which as level 9 of our guide reminds us, as the ultimate entropy storehouses, will eventually evaporate into nothingness through Hawking radiation. Think of the entire universe like a cup of gourmet coffee left out on a table for a billion years. It doesn't just get cold, it reaches thermal equilibrium. It becomes the exact same temperature as the room around it. At that point, there is no gradient, no flow, and no heat exchange. The coffee is stagnant. In the universe, this deep freeze happens in 3 agonizing slow phases. Phase 1, the degenerate age, in about 100 trillion years. The last embers of the last stars will extinguish, leaving the universe in total darkness. Phase 2, the era of decay. In 10 to the power of 65 years, even solid matter may begin to lose its grip as atoms themselves potentially decay. Phase 3, the black hole era. In 10 to the power of 100 years. A number so large that if you fill the entire observable universe with sand, you still won't have enough grains. The largest black holes will finally evaporate. At this point, the universe reaches maximum probability. There are no more clumps, no more structures, just ghost particles drifting in a vacuum near absolute zero. Because there are no more temperature gradients, no energy can flow, no work can be performed, no life can think. And here is the most profound part. Since entropy can no longer increase, the arrow of time effectively disappears. Without the shuffling of the deck, you can no longer distinguish the future from the past. Time does not just stop, it loses its meaning. It feels like the ultimate game over, a dark, static eternity. But is it possible that in the middle of this infinite nothingness, the dice could be rolled one more time? To find out, we have to go to the very last level. Level 10, the ultimate loop, eternity and the Poincaré recurrence. After trillions upon trillions of years of darkness, it feels like the ultimate game over. A static, frozen eternity where the director has finally walked off the set. But is the deep freeze really the end? Level 10 brings us to the most mind-bending loophole in all of physics, the Poincaré recurrence. While the laws of physics give us that stubborn arrow of time, the laws of mathematics reveal a staggering second act. The French mathematician Henri Poincaré proved that in a closed system with infinite time, the particles of that system will eventually return to their exact original state. Think of a standard deck of 54 playing cards. You start with them perfectly sorted by suit and rank. Then you start shuffling. The deck becomes a mess of high entropy. But if you are an immortal being and you keep shuffling that deck forever, eventually, purely by statistical chance, you must shuffle them back into their original, perfectly ordered starting sequence. It might take a number of years so large that you'd need 1,000,000 universes just to write down the zeros. But in an infinite timeline, the impossible becomes inevitable. Our universe is essentially that deck of cards. Even in the dead high entropy void of the heat death, those ghost particles we mentioned are still moving, bumping into each other in the dark. Over a span of time so long, it makes the current age of our universe look like a single heartbeat. Those particles will, by pure random luck, eventually arrange themselves back into the dense, highly ordered configuration of Big Bang. The ultimate loop suggests that the heat death isn't a tomb. It is just a very long, very slow shuffle before the next game begins. The end of our universe might just be the quiet preparation for the next Big Bang. This brings us to the final realization. Entropy is not just a measure of decay, it is the pulse of the universe. We have climbed from a messy room to the rebirth of the cosmos. If there's one thing I want you to take away from these 10 levels, it's this: entropy is not a villain. It is the reason anything happens at all. We only exist because the cosmic waterfall has not finished falling yet. You are a complex, beautiful pattern formed in the steam of a cosmic engine. So don't worry about the disorder. In the grand scheme of the universe, you are just doing your part to keep the arrow of time moving forward.